Hello students, are you struggling to draw resonating structures? Believe me, you are not alone. Therefore, in today's video, I am going to simplify resonance for you and how to write resonating structures. Welcome back to Organic Canvas, where we learn concepts by solving questions. And today's question is to write the number of resonating structures for the given carbanion where the negative charge is on the secondary carbon atom. So the given molecule is a carbanion. What is a carbanion? It's a reaction intermediate which is negatively charged. This is our starting molecule, right? And whatever the negative charge is there, I write it as 2 electrons. That way it is easy to imagine that where the electrons are moving. Okay? And also you see this is a heterocyclic group or heterocyclic molecule because the nitrogen is a heteroatom. The rest of them are carbons and nitrogen is a heteroatom. Now, the negative charge is moving from atom to bond, right? When this happens, look at this carbon. The carbon is having 1, 2, 3 and there is a hydrogen here, 4 bonds already, and the new bond making this carbon pentavalent, which is not possible. The carbon cannot have that pentavalency. So what happens immediately when the electrons move from atom to bond? The electrons here, the pi electrons will move from bond to atom. So how do you write the next structure? The next structure is written as, first you write the parent chain. Okay, whatever is the parent chain, you write that first. Then you write what is not changed. These bonds are unaffected. You write that, right? And the electrons are moving here. So there is a new pi bond formation. And the electrons are moving from bond to atom. So the electrons are on the atom. Okay, whether it is primary, secondary, we will do it later on. First we will write all the possible resonating structures. Okay, so now once you know how to write the parent chain and how to write the bonds, etc., you can quickly start writing the next structure. Move on here, atom to bond, bond to atom, not changed, newly bond form, and the electrons are moved here, right? Atom to bond, bond to atom, right? So since it's a resonance, right, you are using the double-headed arrows, right? So it shows that the electrons are continuously moving, right? Atom to bond, and the negative charge is on nitrogen. Since nitrogen is electronegative element, it can withstand that electronegativity. So then what happens? The electrons will move here. Look at this. We have not formed any negative charge on this as of now. So it will move again. You have to write all possible structures. Okay. So that's why, see here, this is a negative charge like this, and there is a new bond formed here. So that's why it is bringing aromaticity to this particular cyclic molecule. So finally when the electrons move here, right, the electrons will move on this. You have to get back your structure whatever you started with. Till then you have to write all possible resonating structures. And remember students, more the resonating structure, more will be the stability, isn't it? Now, so once you've moved here, there is no point in doing it again and again. It's the same structure. So finally the electrons will be given back. That means you're going to get your original structure what you have written earlier, right? So you're going to get that structure. If you want, you can write that again, no problem. Okay, so how do you write the structure? So look at this. The electrons are moving here. There was already bond here, the double bond, and you got back the structure like this. Now The question is, how many structures will be there where the negative charge is on secondary carbon? First, what is secondary carbon? When a carbon is attached to two carbons, right, then we call this particular carbon as secondary. Let's identify where we have. Look at this, this is primary. Okay, then when the electrons moved here, right, one carbon is here, one carbon is here, therefore secondary. The third atom is nitrogen. Students, remember, this is nitrogen, so it cannot be tertiary. Many students get confused here. Okay, it's attached to 3 atom, tertiary. No, it's attached to nitrogen, therefore it will be not considered, only these two, so secondary. Now let's check this one, 1 and 2, secondary. Let's check this one, it's on nitrogen, so we don't have to do for this one. Let's see here, 1 and 2, so secondary. What about here? Only one, okay, it's nitrogen here again, so it's primary. What about here? We have already done it, it's primary. Now the question is, how many secondary? So let's see here, 1, 2 and 3. There are 3 carbons, right, which are secondary where the charge is negative, which is a carbanion. Hence the final answer is 3. I hope you have understood this, and if you still have any questions on resonance, you can ask the questions in the comment section. Thank you for watching this video.